Hey there, and welcome to a continued dialogue about how we graph trig functions. Let's start from the beginning, which is a very good place to start. All right, so the amplitude, oh, forgot to say, we are assuming that no phase shift have taken place with these functions, okay? So we're going to go ahead and just put that phase shift in as 0. So let's start by identifying the amplitude. The amplitude is going to be the distance to the peak from the midline. So it's going to be 5. And so from our parent function of y equals sine of t, we're going to add that 5 in. Now we want to know, does this sine function have a reflection or not? Now, since we know that there has been no phase shift, and we know that our parent function really goes through the origin and has a peak and then a valley, then we are going to say that there is no reflection, because if there was, it would have a valley first and then a peak. So no reflection. Now we need to identify the period, and remember that the period is the distance on the x-axis it takes for one complete cycle. So in this case, our period is 2 pi over 3 units. Now again, we need to, once we find the period, we need to use that to solve for b. So 2 pi over b is equal to 2 pi over 3, and that means b will equal 3. So we can go ahead and add that in to our function. Y is equal to 5 times the sine of 3t. And in this case, there's no vertical shift because our midline is right on the x-axis. And so we have found our function. And we don't need to put the plus 0 there at the end, but our function that corresponds with this graph is y equals 5 times the sine of 3t. Here's another example, similar to the one we just did. So let's go through it a little quicker this time. How about that amplitude? Can you identify the amplitude? If you said 2, you'd be right. The amplitude is the distance from the midline to the maximum. So that will be 2 units, and we can go ahead and add that into our function. Now we want to know, does this have a reflection? And since there is no phase shift, I look at the y-axis and notice that it is going down to a valley before it goes up to a peak, which means yes, there is a reflection. So we're going to go ahead and add that negative to the coefficient of sine of t. Let's identify the period of this function. Remember, the period is the distance it takes for one full cycle, and that looks like it's pi over 3 units here. So then we will use the period to solve for b. 2 pi over b is equal to pi over 3, and so b is equal to 6. And that means that I can add that 6 value in as the coefficient t. Okay, we are assuming no phase shifts, and this function doesn't have a vertical shift either. We know that because the midline is right on the x-axis. So we can go ahead and identify our function to be y is equal to negative 2 sine of 6t. Here's another example for you. Okay, so this one, we are looking at just one period of this function. And I chose this example because I want you to get in the habit of really being able to identify period. If you can't see several periods, right, you need to kind of pick out one. So let's go ahead and work through this example. The amplitude here is a little harder to find because we don't have all the increments on the y-axis named, but we can say that from what we're given, we can say that this is 8 units. So our amplitude is 8, and we can put that in the appropriate place in our function. Now, what do you think? Does this have a reflection? Is this reflected over the x-axis? How do we know that? Remember that we can look, since we know this has no phase shift, we can look at the y-axis and see what the behavior of the graph is directly to the right. Since it's going down into a valley first, we know that there is a reflection. So yes, there is. We need to add a negative to that coefficient. Now, how about the period here? For one complete cycle, one hill plus one valley, we need to look and see how long that is, okay? And we can tell that that is 6 pi units long. So our period is 6 pi, which means we'll use that to solve for b. 2 pi over b is equal to 6 pi, and that gives us b is equal to 1/3. Okay, so we can put that in the corresponding place. And again, there's no vertical shift. And so we know what our function is. This last example, this is one where I've put a vertical shift in it so that we can see what to do with that. And when there's a vertical shift, you can tell that has happened because the graph is no longer centered over the x-axis. So you need to kind of look and decide where is the midline now. And it's a good idea to go ahead and just sketch that in, because once you sketch it in, it's easier to see what all the components are. Okay, so let's go ahead and find the amplitude, which remember is the distance from the maximum to the midline, okay? And in this case, we have 4 units here. The amplitude then is 4. Go ahead and add that in. How about the reflection? Is there a reflection? Look directly to the right of the y-axis since we know no phase shifts have happened. And we can see that we initially go up to a peak from the y-axis. So there is no reflection here. How about the period? The length of the period here. Can you see it? You write down what you think it is. Okay. You should have gotten 4 units. So 1 complete cycle. And so we can use that to determine b. 2 pi over b is going to equal 4. So b will equal pi over 2. While this function does not have a phase shift, it does indeed have a vertical shift, right? The midline has been shifted up 2 units, and so that means our vertical shift is up 2. And we can add that on to our function. So our completed function will be y is equal to 4 times the sine of pi over 2t plus 2. All right, that takes care of this one. Okay, so once you've gotten familiar with that, you're ready to actually graph on your own. And that's where we'll pick up next time.